Hello students, in this video we're going to learn how to solve trigonometry equations. So do get ready a pen and some papers and practice along with me. To solve trigonometric equations well, we will need to familiarize ourselves with the trigonometric formulas. Trigonometric equations can be solved by simplifying the equations given. Simplifying meaning that we can employ the Pythagorean identities or the reciprocals or the ratio identities. Sometimes you may need to factorize common factors before you can use these identities. So in the next few slides, I'll show you some examples on the trigonometric equations that you need to familiarize yourself with. Right, trigonometry is a huge topic. So beside your Pythagorean identities, your reciprocals, the ratios that we talk about, ratios meaning if you can write tangent theta as sine theta over cos theta, or cotangent theta can be written as cos theta over sine theta. We also have the addition formulae that you need to familiarize yourself with, the double angle formulae, and of course, last but not the least, the R formulae. So these are the ingredients that you need to possess before we can solve problems in this chapter. Let's look at example 1 where we need to use the ratio identity tangent theta equals to sine theta over cos theta to solve this equation. 3 cos x plus 2 sine x equals to 0. The values of x must be between 0 and 360, not inclusive. So first of all, we're going to divide both sides of the equations with 2 cos x. But before that, let's move 3 cos x to the right hand side first. So you have 2 sine x equals to negative 3 cos x. And then you divide both sides of your equation with 2 cos x so that you get tangent x equals to negative 3 over 2. What are the steps involved solving trigo equation? Yes, finding the reference angle. Finding reference angle is a very important step. So to find the reference angle, we ignore the negative sign because reference angle is an angle that's between 0 and 90. It's an acute angle. So therefore, your trigo ratio must be positive. So the reference angle we get here will be 56.31 degrees. Express all your angle in degrees to 2 decimal places, except for the final answer, which should be expressed to 1 decimal place, unless otherwise stated in the question. Right, so let's go back to tangent x equals to negative 3 over 2. If you were to recall your ASTC, tangent is negative in the second and the fourth quadrant. Right, so how do we get x equals to 123.7 or x equals to 303.7? Right, this is how we do it. As explained just now, the value for your tangent ratio is a negative. So the possible quadrants are at the second and the fourth quadrants. So to get the answer at the second quadrant, we would use 180 minus away your alpha. And to get the answer in the fourth quadrant, we use 360 minus alpha. So in other words, if your answer is the first quadrant, x is just alpha. If your answer is in the second quadrant, it's 180 minus alpha. If your answer is in the third quadrant, it's 180 plus alpha. In the fourth quadrant, it's 360 minus alpha. Let's look at example 2, where we need to use the identity to solve these questions. 7 tangent y minus 4 equals to 2 over cos squared y. Many of you may be tempted to use the ratio identity to write tangent y as sine y over cos y. Because of the fact that on the right hand side we have 2 over cos squared y. I would advise you not to, because using that method will lead you to more steps. And sometimes the more steps you have, the likelihood of making mistakes, it's higher. So what we're going to do here is to use this identity, 1 plus tangent square x equals to secant square x. So how did this secant square x come about? Right, let's examine this term here, 2 over cos square x. We can write it as 2 over 1 times 1 over cos square x. And if you have to recall in the earlier slides, where we learned reciprocal, where we learned that secant y it's equals to 1 over cos y, cosecant y is 1 over sine y, cotangent y is 1 over tangent y. So therefore 1 over cos squared y, you can write it as secant squared y. So with this, we're going to solve this trigo equation. The right hand side will have 2 secant squared y. And I can replace your 2 secant squared y with 1 plus tangent squared y. Right, we're going to simplify the equation by bringing everything to the left, to one side. And you see that we will have a quadratic equation where we can factorize it. So you will have tangent y equals to 3 over 2, or tangent y equals to 2. All right, so if you look at the questions again, the angle you're supposed to find, it's between 0 and 6 inclusive. From here, we know that the angle must be expressed in radian. Right, so the next step we need to do is to find the reference angle for both. So this will be tangent inverse 3 over 2. And when you find the angle, when you remember to switch the calculator mode to the radian mode. So tangent inverse 1.5 will gives you 0.9828. All right. So let's look at the value for your tangent, which is 3 over 2 is a positive value. So for positive value, check your ASTC. Tangent is positive in the first and the third quadrant. So our first answer would be first quadrant will just be alpha, and second quadrant will be 180 degrees minus, third quadrant will be 180 degrees plus alpha. So 180 degrees is pi. So that will be pi plus alpha, pi plus 0.9828. And that gives you 4.12. All right, so but we are not done yet, because when tangent y is equals to 2, we have to find reference angle tangent inverse 2. That gives us 1.107. So y in the first quadrant will just be 1.11. Third quadrant will be pi plus 1.107. 4.25. So therefore, your answer would be 0.983, 1.11, 4.12, and the last answer is 4.25. Right, let's look at the next example. That's example 3. Example 3, we're dealing with double angle. So where does this double angle come from? If you examine the questions, you're given sine 2x. Right. So sine 2x equals to square root 3 over 2. And we asked to find x to be between 0 and 2 pi. So since we're finding the value for 2x first, the range, we will have to change the range. The range will be no longer from between 0 to 2 pi. It will have to be between 0 to 4 pi. Right. Now, there's some special angle that we have to take note of. What are they? They are 30 degrees, 60, and 45. Now, why are these angles special? They are special because the trigo ratio of these angles will give you an exact value. What is an exact value? Means you can actually express it as a fraction. For example, if you were to use the calculator, sine 60 will give you 0.866666, but then that can be expressed as square root 3 over 2. Like cosine 60 is half. Right. You can find all these the values for all the trigo ratio of this special angle using your Picasso. So say, for example, this angle is 60 degree. Right. So cosine 60 is half. So cosine it's adjacent over hypo. So your opposite will be square root 2 squared minus 1 squared. That will give you square root 3. Right. So from here, we can easily find the value for sine 60 to be square root 3 over 2. Tangent 60 to be square root 3. Okay, so on and so forth. Right. So if you were to look at what you're given, square root 3 over 2 happen, yes, to be the value for a special trigo ratio of a special angle, which is 60 degrees. So therefore, your alpha here will be sine inverse square root 3 over 2. That gives you 60 degree. However, you have to leave your answer in radian mode. Therefore, you have to convert 60 degrees to pi, in terms of pi. So 180 degrees is equals to pi. So to get 60 degree means I divide by 3. 180 divided by 3, right, to get 60. So I do it on the other side also. So therefore 60 degrees is pi over 3. The next thing is to look out for the ASTC. So for sine to be positive, the answer can come from the first and the second quadrant. Right, so let's work out the first answer, which is just alpha, which is pi over 3. Second quadrant is pi minus pi over 3. And it has to be between 0 and 4 pi. That means what we are saying is that this particular point P, right, it moves around the circle 2 times. Okay, move around the circle 2 times. So therefore, the original answer, pi over 3, you add one more round, which is 2 pi. Then pi minus pi over 3, add another 2 pi. So finally, you divide by 2 throughout to get pi over 6, 2 pi over 3, 2 pi over 3, divide by, oh my god, calculation is not very good. Okay, that will gives you divide by 2. One minus 1 over 3, divide by 2. Pi over 3, and 1 plus 2 pi, divide by 2, 7 over 6 pi. And finally, 1 minus 1 over 3 plus 2 divided by 2, 4 over 3 pi. All right, so this is how you solve these questions. Well, let's look at example 4, where we need to manage negative angles. Why are negative angles involved? Because if you look at the range that you're supposed to find for the values of x, it has to be between negative 180 to 180. So that explains why you need negative angles. All right, so we will have to find the new range because look at the questions that we are supposed to solve. Cos 2x equals to sine 220. So therefore, the range for your 2x will have to be between negative 360 and 360 degrees. So basically, that's one round, one round of the circle. All right, common mistake. It's some student would just do it this way. And this is a no-no. Why this is no-no? Because sine 220 will gives you a negative value. So cosine inverse of a negative value will gives you an obtuse angle, which is not what we're supposed to get for alpha. Alpha is an acute angle, so you need to cosine inverse a positive value. So if that's the case, what is the correct way of doing it? (220) is 180 plus 40. So sine 220 is actually equals to negative sine 40. And if you were to recall your complementary angle, that cosine theta is equals to sine 90 minus theta. Sine theta is equals to cos 90 minus theta. Sine 40 is just negative cosine 50. Sine 40 is cosine 50. Right. So therefore, cosine 2x is equals to negative cosine 50 degrees. And therefore, alpha is just 50 degrees here. You have to ignore the negative. Okay, ignore this because your alpha is a positive acute angle. So therefore, alpha is 50 degrees. All right, so some of you may ask, how about if I do it this way? I have cosine 2x equals to sine 220. I just use a calculator to work out sine 220, which I get negative 0.64278, let's say. And then I find alpha, which is cosine inverse 0.642788. And let's see what's the value you get for your alpha. You'd see that you'll get 49.9999, which is not the exact value. I'm not too sure how much you'll be penalized. Okay, probably 1 or 2 marks. And of course, you can, if you want, you can just approximate it to 50.0. You can't write as 50 because you don't get exactly 50. So you would to approximate it to 50.0. Okay, right. So that's erase this. Okay, so now let's look at what we're supposed to get for 2x. Let's concentrate on the positive angle first. So let's draw your ASTC. Right, so for your cosine to be, since we're dealing with a negative, so it will come from the second and the third quadrant, right? So for the positive angle, this is your positive angle. It goes this way, right? This is your alpha, this is your alpha. Right, so your first value will be 180 minus 50. Right, and then from the third quadrant will be 180 plus 50. So from here, you get x is equals to 65 degrees. (115 degrees). All right, that's it. Okay, we just need to do between 0 to 360, just one round. So for your negative angle, okay, maybe we use the same diagram. Okay, from your negative angle, but we use a different color. It goes this way, right? Right, so if you go this way, you will see that for the negative angle, this become the second quadrant, and this become the third quadrant. All right, so for your negative angle, make sure you put the negative in front. So for the second quadrant will be 180 minus your alpha, which is 50. Then for your third quadrant, put the negative 180 plus alpha. So you will end up getting negative 65 degrees, negative 115 degrees. So therefore, your answer would be x equals to negative 65, negative 115, 65, and 115. Right, so this is how you do it. Right, let's look at the last example. Last example involve us having to apply the R formula. Let's look at part I. So we're asked to use this, the R formula, to solve this equation. Okay, so R cosine theta minus alpha, if we were to apply the addition formula, that will give you R cosine theta cosine alpha plus R sine theta sine alpha. If you've forgotten your addition formula, please do a recap. Okay, we're going to compare this R cosine theta cosine alpha with 7 cosine theta plus 4 sine theta. Right, so R cosine theta cosine alpha can be compared with 7 cos theta. So this and this goes off, so that give us r cosine alpha to be 7. That's equation 1. And then r sine theta sine alpha give me 4 sine theta. This and this goes off. So we have r sine alpha equals to 4. Call this equation 2. When I take equation 1 square it plus equation 2 square it, we would have r squared cos squared alpha plus r squared sine squared alpha. That gives you 49 plus 16. So you factorize your r squared out, and you're left with cosine squared alpha plus sine squared alpha. 49 plus 16 will give you 65. And if you remember your Pythagorean's identity, cos squared alpha plus sine squared alpha gives you 1. So r squared is 65. You're told that r is positive. So r will be just square root of 65, which is, if you want it to be very accurate, you can just leave it as I think you can just use a calculator to evaluate it. That will give you 8.0623. All right, and then what's the next thing I need to find? I would have to find my alpha, right? So to find my alpha, I would just take equation 2 to divide by equation 1. R sine alpha divided by r cos alpha. That gives me tangent alpha. So alpha will be tangent inverse 4 over 7. That will be approximately 29.74. Oh, your theta must be between 0 and pi radian. Sorry. So we need to change the calculator mode to the radian mode. So tangent inverse 4 divided by 7. And that gives you 0.5191. All right. So if you put everything together, this is what happened. So we will have r cosine bracket theta minus alpha, which represent this one, equals to 6, right? So I put in my values for the r, which is 8.0623. Cosine theta minus 0.5191 equals to 6. So cosine bracket theta minus 0.5191 will be 6 divided by, I should leave it as square root 65. Okay, so from here, it's pretty easy already. You will see that the alpha, you will see that the angle is between 0 and pi radian. And for cosine to be positive, come from the first and the third. So we just need to consider the first quadrant that will do. First quadrant. So we just have to cosine inverse this value. And theta will be cosine inverse that value plus 0.5191. And that gives you 1.25. Right, so that's first part of the answer. All right, we need to make use of the answers we found in part I to solve part 2. But if you look at what we need to find in part 2, we're asked to find the largest and the smallest values of 80 minus bracket 7 cos theta plus 4 sin theta, close bracket squared. So I think it would be advisable to leave your r as square root 65. Okay, I'll explain later why. So it's advisable to leave it as square root 65. But for part I, it's fine. You can leave it as, put it as 8.0623. Okay, why when you do that? Because if you leave it as 8.0623, and if you square it, you will not get an exact value. You only get exact. All right, but if you leave it as square root 65, and you square it, you will get exactly 65. So for part 2, it's advisable to leave your r as square root 65. But in case if you don't leave it as square root 65, then will you be penalized? I do not think so that you will be penalized. As long as you show your steps properly and you leave your answer, final answer to 3 significant figure, and for angle, it's 1 decimal place, unless otherwise stated in the question. All right. So there are 2 things we need to find, the largest and the smaller. So let's start off by finding the largest first. So to get the largest value for this, 80 minus bracket 7 cos, sorry, I'm just going to replace that with square root 65. All right, so to get the largest value for this, it means that we need to have the smallest possible value for this expression, right? And what is the smallest value you will get when you square any number? When you square a negative real number or positive real number, what is the smallest value you can get? Yes, 0. So therefore, the largest value is 80. Okay, and we also ask required to find the corresponding value of theta. So where does this corresponding value of theta come from? Will come from this part here, where we agreed earlier on that this should be 0, right? Because the smallest value is when you square any negative or positive real number is 0, right? So you will end up getting cosine bracket theta minus 0.5191 equals to 0, because 0 divided by square root 65 will give you 0. All right, so if you were to recall your cosine curve, to get your y0, the first value, your reference angle would have to be this value here, which is 90 degrees pi over 2. So therefore, cos theta minus 0.5191 will be equals to pi over 2. And hence, theta will be approximately 2.09 expressed to 3 significant figure. So if you leave your answer at 8.0623, then your largest value will be 14. Sorry. No, this one is all right. This one is all right. It's the smallest value. Okay, sorry. Let's look at how we find the smallest value. All right. So the smallest value will be 80 minus. This expression needs to be the biggest. The biggest is when I square it, right? The biggest value for your cosine curve, your biggest y value is 1. So that means the biggest value I have will be square root 65 times 1 squared. And that gives me exactly 15. So if you leave your answer as 8.0623, what happened is you will get 14.9999. and then your answer will have to be 15.0. You would have to put a 0.0 there because what you get is not exact, right? So you can't, your answer is not 15 but 15.0. All right, and that happened when your cosine theta minus 0.5191 is equals to 1. Right, so to get 1 means, look at the graph, is cosine 0 degree gives you 1. So this will be 0. So therefore your theta will be 0.519 expressed to 3 significant figure. All right. So that's the end of this video on solving trigo equations. Happy learning!